Good morning, lovely people. What the hell is happening here? Okay, so before I have some new speakers that I want to test. So one of the last videos was testing the tweeters that I have, which is can speak against the SB Acoustic that I recently bought. Now I decided to test some more speakers, mid-ranges and mid-bass. So let me explain what this is, and then I'm going to explain how and what I'm planning to do. I think this is going to be a long video, so we'll see. So first of all, the drivers. This is my mid-bass that I have in the kicks now, and this is my mid-range that I have in the dash. So I pulled one out from there, the other one is still there. I pulled one from the kicks, and this one, so these two are Peerless drivers, these both SB Acoustics. So in the kicks, SB Acoustics SB17, so MFC is the, I think it's polycarbonate or whatever it's called, it's like plastic. And this is the Satori MW13P 5-inch driver. And these are Peerless drivers. So this is, oh my god, it's very difficult to show you. 830875 and the matching 830870. So this is I think it's a 4-inch and this is a 6.5. So I bought this one, Peerless one, literally like more than a year ago, and I just had it. I made a bookshelf speakers with these, and they sound very, very good. And these, very recently, these small ones, I won an eBay auction for £15 plus shipping for two, for a pair. So that's, plus shipping's like less than £10 per driver. And I just thought I could do some distortion measurements. I can pop them in where I have those drivers and just see if it would be an upgrade from SB Acoustics or not, you know, because I have these drivers, I like to play with the stuff. So yeah, so I'm planning to do distortion measurements same way as for the tweeter, just a little bit different. So I have this MDF board that I just popped it for, so it's like 12 mil. I'm planning to cut, this is gonna be like a baffle for me, so I'm planning to cut like a hole somewhere like close to the middle. I'm gonna start with the smallest driver for the 4-inch. I'm gonna cut a hole for this, put this in, put that board somewhere there. I don't know how yet, but I'm gonna figure it out. I have a microphone, I'm gonna put it somewhere there as well, and probably near field because it's gonna measure low. And I'm gonna take distortion measurements for this one. Then I'm gonna swap, make a bigger hole for the 5-inch, make a bigger hole for the 6-inch, and the biggest one for this. I think these two should be the same hole, but the plan is to make measurements for all of these drivers and just to check which have the least distortion, because distortion is not mentioned anywhere in any of the TS parameters or anything. So yeah, because like for example what I have now, these, yeah, they play very low, they have very soft suspension. We're gonna go through the specs, but the thing is I don't need them to play low because I have a front sub, so I need them to play from like 90 hertz or whatever. So this can do the job exactly the same. And a lot of people say that the SB17s, these ones, they have lack performance in the mid-bass but excel in the mid-range. That's why it's very good to have these in a two-way paired with a tweeter. And I need them specifically for mid-bass. They don't play any mid-range. They are cut off like after 200 hertz. So my thinking that maybe the Peerless is gonna be a bit better for that. And the Satori that I have in the dash as well, it's a 5-inch and it's oversized 5-inch, and it's an overkill because it can play easy down to 100 hertz, but I don't need that. I don't need it to play from 200. And these have an FS of, actually let's check now, and let's check and compare a bit. So the Peerless FS, if I can find it very fast, 91 hertz, and I did check it with impedance measurements. It's about 90 hertz, so they can play from 180, and that's exactly where I need them to start playing. And even this, it shows like they start from 150 going down from 200, and this linear up to, it's like, it doesn't show, but it's like, I don't know, 7-8K. And the Satoris, if they're on axis, they have a peak at about 8K cone breakup, and they have a dip here, which it shows in my measurements as well, and I don't like it. And these don't have that dip, so hopefully it's gonna be a bit more linear. And these are a bit overkill. So these have, where is it, FS 41, so you could play them from 80 and down, so they do play down to 100 hertz. Now let's check a few other parameters, just compare these two. So these obviously are a bit smaller, they beam a bit higher, and it's kind of better for me because they aimed, as you can see, they're aimed directly at the glass and they're firing there. Let's check inductance. So for these, the Satori inductance is 0.13, and where is it here? If I can find it, there we go, 0.16. So it's basically the same. Yeah, the main difference is the stiffness. So if we check compliance and bass, so this is 14 liters and this is 2 liters. So these are much stiffer than the Satori. Satori is extremely, look, extremely, it's barely putting any pressure. Extremely soft suspension, very soft. And these are much stiffer. They're still not very stiff, but compared, they're much stiffer. The only downside to the Peerless is they're 6 ohms. These are 6 ohms, and those are 8 ohms, and both of these are 4 ohms. So, but I'm not too worried about this. So they're similar, smaller ones, and these two, yeah. So the cone area of the Peerless is a bit bigger because the Peerless, where is it, SD 143, and for this one 118. So these are kind of 6 and these are 6.5, something like that. So these are a bit bigger. I'll have more cone, so that's a good thing, no? So LE 0.41 for the Peerless, and for these LE is, if I can find it, oh my god, 0.13. So these had much lower inductance than the Peerless, but at the same time they can handle like 60 watts. These are 75, so these can handle a bit more, and they're stiffer, so the coil is a bit different, you know. Moving mass, let's check moving mass, 15.9, and on these ones 12. So again, a bit lighter cone. This is a bit heavier just because of probably the coil, I don't know. And let's check moving mass for this. That's 7.2 for Satori, and where's the MMS, 6.1. So since it's a smaller cone in general, it's a smaller speaker, it's less mass, yeah. And yeah, I'm not really concerned about like X-Max coil chow, so that's 5.5 mils. This one has 5.3. It's kind of the same. I'm not worried about X-Max because I'm not running them low, so they're not gonna bottom out anyway, because I'm not running them low as possible. They're gonna play down to 90 hertz, so there's gonna be no excursion. It's the same for the mid-range. If they're gonna play down to 200, there's gonna be barely excursion. Like these play down to 200. When they play, I cannot see them move at all, so I'm not worried about excursion. It's in my application, it doesn't really matter. Yeah, so these are beautiful drivers. I love how the way they look. has a chunky motor. So one main difference is that Satori is a neo magnet, so it's much smaller, and this is a bit thicker. However, this is lower mounting depth because it's a smaller speaker. And for these two, they're exactly the same. The only difference is going to be the cone, because if I put them like this, I'm going to try to show you. There we go. So the Peerless has slightly larger basket, so I will need to make, that's why I'm not going to measure the frequency response today, because I need to make special adapters for them to fit, because like my dash is made for these and these are smaller, so I need like a adapter ring. And exactly the same for this, I need adapter ring because the basket is slightly different and the mounting holes are different, because like Satori has 4 holes and this one has 6. Weird. So yeah, I will need to make mounting adapters for these. But now that's like visual comparison and the teal small parameters, what's important for in my case. And now I'm gonna set up the rig and I'm gonna show you how I'm gonna measure the distortion for these drivers. Okay, so I'm ready to make some measurements. Actually did some as a test, but let me explain what I have. Audio interface, loop back into the DSP back. Then from the amplifier I have cable that go into the speaker. Director inside is maxed out, and I'm going to be controlling the volume. In here is going to be very difficult to see. I do apologize because it's very sunny. So here, when you do the measurement, you can change the level, which one you want. And in the DSP, it's impossible to see, but I have, there we go, 24 dB at 100 Hertz crossover. For now, I'm going to be testing different crossovers as well. And the main idea is, so that's a baffle. I have a few woods, screws, and the thing is, now I don't know how to do this, because I don't know, should I do it like near field as possible? Should it be like some distance, 20 centimeters, 1 foot, half a meter? I have no idea how to do this, but the main my logic is that this baffle has like a certain dimensions, so the back wave on the lower frequencies is still going to go through, especially for the 6.5s. So it has to be near field, as close as possible to the cone. So I'm going to just adjust it now. It's just some testing to do like that. And I think it has to be near field, because the thing is, the main thing is to measure all the drivers in the same way, so it's going to be consistent. So at the moment I have made a few measurements and I don't know if they're correct or not. So for example, this one I did from like 30-40 centimeters away on full tilt, and it shows me like 0% down to 100. Then I took a near field one, extremely close and full tilt. It shows me 5%. So is the same volume, just near field. So I think it might be the microphone, I don't know. And then I took it on a lower level, minus 15 dB. Now it's showing me like 1 to 2%. So I don't know, I will need to play with this. But the main thing is consistency. So I have to make all the measurements in the same way, and it's going to be with different crossover frequencies. But basically this is the... Oh, another thing that I mentioned, the charger is on supply. It's not flashing, it's flashing through the camera, but in reality it's not flashing. So it's in supply, 30.6, stable voltage, the amps are happy, everything. And one thing that somebody mentioned as well, when I did the tweeters, and they said that you should test distortion not on the same settings of output on, like, I put on the director in front. So like not with the power that you're sending to the amplifier, but on the same volume all the drivers. So like 90 dB, all of them, 100 dB or 80 dB or whatever. So my plan is to use this. So this is a weighted, just a cheapy thingy. And the thing is, like, consistency doesn't matter. So what I'm planning to do is, when I'm playing, like, check levels. So at the same time, while I'm checking the levels, you see it's like 92 dB playing. So I'm gonna check the volume and make sure it's more or less the same. It's not gonna be perfect, because you have to realize this, like, all my measurement that I'm doing, like in my backyard, it's not a scientific laboratory. And this is just for purely comparison reasons. I'm not, like, this distortion that I'm after, that I'm measuring, I don't really care if it's 0.5% or 2%. What I wanna see is the difference between how the crossover affects it and the difference between the drivers. So how accurate it is, I don't care. I just want to know if the Peerless or ASB Acoustics has less distortions. That's all what I'm after. Yeah. So yeah, I'm gonna play with this, and when I'm done playing, I'm gonna present you some of the results. Yeah, it will take me probably a few hours or even more. Okay, on to my second driver. So I decided to do something like this, which is almost near field. And I decided to do, so with this one, I was checking like the levels. So it was 110 dB and 100 dB. So two levels, 100 and 110. And then crossovers 100 hertz, 50 hertz, and 200 hertz for the mid-range. And what I noticed straight away, so on this one, on the other one, Peerless, on the Peerless, the smaller one, to hit 110, I had to do minus 7 dB, and now I need to do minus 9 dB. So it looks like these Satori is like 2 dB more efficient, because probably these are 4 ohm and those are 6 ohm or 5 and something ohm. So I think because of that. So just an update. But yeah, measurements are going. I'm having the results. I'm continuing measuring. WTF. Imagine that, in the middle of measurements, my laptop totally went blue screen on me. Oh my god, that literally, this laptop never ever blue screened, ever. I don't know what's wrong with it. Okay, I just saved my measurements, so I hope they're gonna stay there. I literally just managed to save them. And okay, yeah, let's try. Okay, I have all the measurements done. This is the last Peerless driver. I created separate files for separate drivers, and after that blue screen, the good thing, like, if you open REW again, it says like, oh, you have some unsaved measurements, do you wanna open them? And I clicked yes, and basically now I have is this one. So I have the measurements, however none of them are named, see? So I'll have to go through them, because again I put it the 4-inch back in there because the hole is too big. So I'll have to go through them again and just to figure out which was which. So for the mid bass, I chose crossover frequency at 80, 50 and 30 hertz, just to see. And just for example, this Peerless, I'm gonna go through all the measurements. This Peerless at full tilt, it has like 5%, and then it rises up to like 40%, but this is cross at 30 hertz. So I will go through all the measurements. But yeah, all the measurements are done, 4 drivers. And again, just to emphasize, this is nowhere near perfect. It's not, maybe even it's not supposed to be done like this. However, for consistency, I measured all the drivers in the same way, so with that I can compare them between the two. I don't care about the actual values of the distortion. What I want is to know which has less distortion, which produces less distortion. And I chose this infinite baffle application just because my kicks are infinite baffle and my dash is infinite baffle. So it's in the same application, so I could know what to expect more or less. Okay, so let me work with the data. I'm gonna check everything and I will come back in a minute with the view in the laptop. Okay, so finally I have all the data. I have different files for different drivers. So let's check. Let's start with the mid-ranges. And let's take, so let me explain a bit. This is 110 dB and 100 dB, so two different levels, 10 dB difference, and three different crossovers, 200 Hertz, 100 Hertz, and 50 Hertz. That's for the mid-range. Now, I'm not expecting to cross the mid-range 50 Hertz, but it's good to see the distortion at if you don't apply any crossovers and stuff. So this, the dB, again, kind of ignore it because it was just for the purpose of making sure that the both drivers are measured at the same loudness. So it's not like 1 meter on 110 dB. It doesn't matter. It's just to make sure that they are both the same. And let's take the worst possible scenario. So almost full tilt, crossed at 50 Hertz. So this is the Peerless, and as you can see, the distortion is is about 2%, and it rises below 90 Hertz up to like 7. Now this is the Satori. So same, you have 2.5%, then it goes down and it goes up. So let me just toggle between two. So this is Peerless, Satori, Peerless, Satori, Peerless, Satori. So Peerless might have a tiny little bit less, but I think it's the same. It's just error of measurement. The only difference that I see, you see the third harmonic here on the Peerless, it's very pronounced, whereas on Satori, it's not. And this is the crossover region because you cross it to the tweets at like 3-4K, 2-3-4K, somewhere here. So I don't know if it's going to be very audible. Comment, please, what do you think about this? Let's check other stuff. So like, let's reduce the level. This is normal, like more normal listening levels, and cross at 200 Hertz, where they're supposed to be crossed. 200 Hertz, and let's toggle between them. So let's see, Satori 0.7, and this one kind of here 0.6. So again, almost identical. The bottom end, like below 150, it drowns in floor noise. Here I have some floor noise because I measured outside, so I have some floor noise. Here as well, like a peak of floor noise. It might be a resonance or something, but again, this, the third harmonic here, pops up. But it's kind of the same. The Satori, what I noticed, it has a problem like at 1.5K, and it's in all the measurements everywhere, and it's even in the frequency response, that dip. And I don't know why it is there, but yeah. So as you can see on the lower level measurement is just a lot of floor noise, but on a higher, this is crossed at 50, at 100, at 200. So the distortion goes down in the crossover region. And exactly the same for the Peerless one. 50, 100, 200. It goes down. So very loud on cross at 200 Hertz. You have 2%, and maybe tiny bit more for the, but again, it's just an error of measurement. We see extremely similar performance. Maybe Peerless has a bit less on the top end, but it has that third harmonic, which is very pronounced. And Satori has a peak at like 8.5K, which is the cone breakup. But it's really similar, extremely similar. Yeah. Now let's have a look at the mid bass. So this one and this one. So here we have Peerless 6.5, and this is the SB17. And again, worst case scenario, for the mid bass, I play them a little bit louder, and I cross them at 80, 50, and 30. Again, you're not going to cross them at 30 in the doors. Probably I'm going to cross them at 80, but again, just to see how they perform. So let's toggle between two of them. Again, extremely similar. The main difference is here, which I'd not bother because I'm going to be crossing them at like 200, 250. So I'm focusing on this region between like 70, 80 and 200, like this region here. And kind of the same. The only difference here on the bottom end, you can see this, the third harmonic for the SB17 pops up below like 50, 40 hertz. And for Peerless, it's not that pronounced. Let's lower the, put the crossover higher at 80 hertz, where I'm kind of intended to use them. So you see, if you go from 30, 50, it brings it down, and 80, it brings it even more down. And let's compare. So Peerless, SB, Peerless, SB. Exactly the same. The only difference again is that third harmonic. So you see on the SB, the third harmonic is like at 2%, but again, it's like 40 hertz. And on Peerless, it's down to 0.5%. So that third harmonic, is it going to be audible? I don't know, comment what you think. I don't think so, because it's going to be like, again, this region, and in this region you have 0.3 and 0.2, so kind of exactly the same. Let's have a look at lower levels. 110, 80, 110, 80. Yeah, exactly the same. Exactly the same. Everything drowns in floor noise. So on normal levels, you have, let's have this region. We have between like 1.3 and 2%. On very high levels, we have a bit more like 5-6%, and on both is the same. And on normal, like lower levels, everything is like 0.5%. It drowns in floor noise. So yeah, they perform kinda the same. Extremely, again, just that third harmonic, which probably is not going to be audible, but extremely similar. Same with the mid-range. But with the mid-range, the difference was in that this third harmonic here, but for the mid-bass, it's kind of the same. So I don't know. So the main question is, will I be swapping them? Yes, just because I just want to compare, just to play. And again, this is my hobby. I like doing that. I like swapping stuff, just checking and everything. I'm going to do another tuning session. So yes, I will be swapping them. And the main thing that I'll be listening to is this one. Will I be able to hear the difference in this third harmonic here at 3.5K in the crossover region? I don't know. We'll see. And some bonus things for you. I did measure my date and sub, the one that's in the central console. So this is full range, no crossover applied, full tilt. And we have, so it's playing between like 40 and 100, like in this area somewhere. And here you have 5-6%, so 6 on the higher end, and 5 and 4%, so 5% distortion on full tilt. Minus 10 dB, that falls down to below 2% and 2%, so I think it's very good for this date and sub. And that's exactly what I noticed, that it plays very clean. And minus 20% on very normal listening levels, it kind of drowns in the floor noise. So we have the second harmonic, or about, what is it, THD, there we go, it's 0.5%, 0.5, 0.7%. It's extremely clean sub. And I did check it with a crossover. so it brings down this into the floor noise. And if I apply both crossovers at 30 and at, I don't remember, 80 or 90, I have a peak at full tilt, 5%, and it goes down. And with minus 10 dB level, that is below 2%. So for a sub, below 2% is amazing. And then, just for fun, because why not, I measured my IB sub. So my IB sub, so this is scaled from 10 Hertz up to 500. And I'm going to be looking at this THD, the main line. Actually, I'm going to remove these so that it would be less confusing. There we go. So THD is this black line. And I have 6%, 6-7% between like 20 and 40, and then it goes down. It's crossed at 60, but I played it full range. And then the distortion rises below because it's just floor noise, goes up as well. So on full tilt on my IB sub, I have about 5-6%, minus 10 level, minus 10 dB level. That distortion goes down to like 2.5%, up to 5% at 20 Hertz. And on normal listening levels with minus 20 on the director, it's like here, 1.5%, 2%, 1%. For a sub, I think it's very, very good. Very little distortion. And again, all of this, what I've done is just to compare. It's nothing scientific. It's just for me to see how those drivers are different, how they perform differently, and will I be able to hear, for example, this third harmonic on the mid-range. That's the only reason why I did this. And it's fun, you know, it's my hobby. It's fun. Cool. So if you have any comments, if you have any tips, advices for me, please post them. And yeah, I will see you in the next one. See ya.